When you think of a chameleon, you picture it vanishing into leaves and bark, changing colors to match its surroundings. Its impressive camouflage hides a trick, layers of pigment cells that are exposed by tiny muscles expanding or contracting. But what if we could borrow this trick and make our own surfaces change color? By copying a chameleon's pigment muscle dance, we could unleash surfaces that blend into any scene. This could reduce detection of surfaces and open up brand new stealth tech. At least that's what Hyeonseok Kim and his team wondered. Could we recreate a color-shifting skin? They rolled up their sleeves and jumped straight into the lab. After months of hard work and experimentation, they unveiled their discovery in a paper titled Biomimetic Chameleon Soft Robot with Artificial Crypsis and Disruptive Coloration Skin. But let's take a moment to ask ourselves, why do we need to reinvent the way we camouflage? Well, existing artificial camouflage systems hit a wall when it comes to resolution. Getting fine detail means packing in hundreds of tiny pixels and a maze of wiring. That complexity kills flexibility and scalability, forcing designers to choose between blurry patterns or bulky, power-hungry hardware. At this point, the team looked to the humble chameleon for inspiration. By tweaking the spacing of microscopic crystal lattices in its skin, a chameleon can sweep across the entire visible spectrum in under half a second, and it does so with almost no energy to spare. They started by making 3 layers of tiny silver wire heaters on a bendable plastic sheet. They added black ink underneath a coating of heat-sensitive crystals that change color with temperature. They then added color sensors and a simple electronic controller. Finally, they stuck these patches onto a soft, chameleon-like robot and put it to the test. What is pretty cool is the chameleon-like robot was able to shift its skin color in 3.04 to 3.52 seconds as it crawls through red, green, and blue zones. Although it's still slower than a real chameleon color change of 0.44 to 0.46 seconds, it is an important step for adaptive camouflage. Now, I think it's a really strong paper that shows a great proof of concept. That said, I would recommend the authors to integrate real-time pattern recognition so the system can choose which heater layer to fire based on the actual background texture. For example, they could add a small camera and a simple algorithm to distinguish dot, line, or uniform patterns, then instantly activate the matching heater design for fully automated, high-fidelity camouflage. All right, now the meme of the week. Thank you all for watching, take care, and be sure to check out our other video on ascene camouflage.